We are live. Well, hello everybody. Sorry for the delay. Looks as though there's some gremlins in the interwebs today. Um, yeah, first time that's happened. Yeah, don't know what to say. Sorry about that. Obviously, we need to. Someone needs to think about some high availability stuff. But anyway, better late than never. Welcome to Serverless Office Hours. Good morning, good afternoon, good evening, wherever you are around the world. Thanks for joining us. Yeah, we're now live on Serverless Land YouTube and the AWS Twitch channel. So yeah, thanks for joining us. Today, I'm super happy that we've got one of the experts in the serverless world, and Dan Fox. Welcome, Dan, who's a principal serverless solutions architect. Dan, tell us, how long have you been with AWS, and how on earth did you land up joining our fun team?
Hi, Julian. Thank you for having me on your show. Super happy to be here. I have been with AWS a little over a year and a handful of months. And prior to joining, I was the chief technology officer at a startup. And we were building a system to track assets and people in hospitals using a hardware technology called ultra-wideband technology that could help us triangulate the distance to a point in a hospital. And then on the back end, our back end was 100% serverless. So I got a really good exposure to a broad variety of serverless services at AWS. And when my startup became a victim of COVID, I decided I kind of wanted to go to the place where they're making this cool stuff.
That is a cool, awesome story. So literally when people think, well, serverless, maybe not for the enterprise, maybe not for hospitals, maybe not for HIPAA compliance, Dan has a story to tell you that he literally built a backend in serverless for a hospital. I'm sorry. Well, in one way, I'm sorry that your startup didn't happen, but I'm happy that you've been able to join us with your cool expertise at AWS.
Yeah, there's definitely a silver lining to that cloud. And as a result, I'm a true believer. So super happy to be here working on serverless.
Fantastic. Yeah, so literally Dan from the trenches. So remember, we are here live. So please, if you have any of your questions about serverless in general, and specifically for Dan, he'd love to answer your questions. So yeah, please send us a message in the chat. We would appreciate it. Just looking back over the past few weeks in the world of serverless at AWS, it's all pre-invent build-up season, which is super exciting. Last week, we looked at one of the sort of pre-invent announcements. I knew I was going to get that wrong, with Brian and Trishika, who did an awesome, cool demo on cross-account ECR support. So when you're building your Lambda functions as container images, you can now pull those from an ECR registry that's in another account. So have a look at that. That's recorded now on Serverless Land, on the Serverless Land YouTube channel. What's new in serverless in terms of announcements coming out? I hate to tell you there's not a lot, and that's for a very good reason, because in about 2 weeks' time, there's a thing called reInvent coming out. So there may be some rabbits being pulled out of the hat across all of AWS. AWS is so big, I don't even know what's going on in a lot of the other organizations. So I'm sure there are people scrambling to get things right and get things ready. So first of all, kudos to them for bringing some cool, hopefully awesome new stuff to AWS. So yeah, just what has happened. The big one mainly is for step functions, which if you are using step functions, or you've got applications running in a VPC, you can now Synchronous Express workflows now supports AWS Private Link, so that is going to be something certainly interesting to you. Then just we've gone back over a slide, and then just looking at the recent AWS Compute blog posts, a really interesting one that I've been using from John and Isael, understanding our AWS Lambda scales with SQS standard queues. So a lot of customers are using a lot of SQS with AWS. So this is SQS as an event source, and this is just understanding how Lambda scales up to meet that demand, which can scale up pretty substantially. So if you're using SQS using Lambda, it's a great blog post which goes through a number of different factors to keep in mind with that. And the other recent one was token-based auth for iOS apps with SNS. So SNS, the part of SNS that does mobile notifications, can now do token-based auth for iOS. So let's just jump into it. It's pre-invent session number 3, and we're doing a slightly different take today. As we sort of going to jump into what it would be like in reInvent if you were attending. Now, I will just pop this slide up to say that you can still register with reInvent. You can join us in Las Vegas, which will be in 2 weeks' time, as I mentioned, or you can attend virtually. So Virtually, there's going to be all the breakout sessions are going to be available pretty soon after they're given live in reInvent, so you're going to be able to do that. And so, yeah, of course, in these travel times, it's super difficult to attend a conference, or maybe you're not comfortable attending a conference, which is completely understandable. So there's going to be a great virtual part of reInvent. But if you are able to join us live in Las Vegas, that is also going to be super awesome too. And that's what I want to talk about today, because we're going through what a builder session is. And so a builder session is one of the ways we are able to deliver some cool demos and content and everything. If you are physically at reInvent, builder sessions are not recorded. So yeah, Dan is doing a builder session. Tell us about your builder session and sort of how they work.
Yeah, if you're going to be live at reInvent, I would really encourage you to check out a builder session. And I know that the breakout sessions and the big audiences are really exciting and sexy and fun to be at. But the builder sessions are a little bit different. They're much more intimate and also much more interactive. So with a builder session, we expect that you would bring your laptop to the session, and you'll be seated at one of a number of tables. I think we have about 7 tables lined up per builder session, and then 9 people per table. And at each table, there's going to be an expert there that is going to walk you through maybe a short presentation probably, but really get you pretty quickly to labs. Workshops and labs where you're actually building content using AWS services with your expert there to speak with, and they're just really engaging and fun. So, if you haven't signed up for one, I think they also leave some space for walk-ins. So if you get to a session early enough, you may be able to just kind of jump in and walk in, even if you weren't able to sign up.
Yeah, that's a perfect way. I think, really the benefit of being at reInvent, there's so many benefits of being there. One is the interaction with other humans. It's been COVID time. We haven't seen a lot of people, so being able to talk to your peers. In previous reInvents, I've literally was one of those people when I was on the sort of customer or user or builder side myself, queuing up to see some of the sessions and literally spending, 30 minutes, 45 minutes just in a group of people in the queue going into a keynote or something like that. And amazing the kind of tips and tricks and things you learn about that. And then the hands-on stuff. The workshops are amazing. They're really, you take your own laptop as well, and you can spend 2 or 3 hours doing something with a workshop, and then take that into a small scale with a builder session. Take your own laptop in, learn from experts like Dan, and actually build something yourself. Obviously guided with the experts, and have someone on hand, in a small session to be able to learn things from. So yeah, that's the real power of actually being physically at something like reInvent, is to be able to do these cool things that you can't do and can't watch a video after the fact. So I definitely would suggest you give a builder session a go. And yes, as Dan says, there are walk-ups hopefully available, so you may need to get there a little bit early. But yeah, you could bag a cool something cool to do in your reInvent schedule.
Nice benefit too of the builder sessions is that typically we'll give you a free temporary AWS account to work in as well. So you don't even have to bring your own AWS account. We'll vend one of those for you, and we have a whole system of distributing accounts. And then you'll have your own account where you can actually, and typically at least in my builder session, and I know in a few of my colleagues that are doing, they have preloaded labs built into the account that gets distributed to you, and so. You get to use it on site, and many of the builder sessions actually allow you to carry that account with you for a short duration afterwards as well. So we have some homework that people might be interested in. So we like to leave people with extra credit. So if they want to engage more deeply, they can continue to have access to that account and work on some of the labs that we provide. So.
Excellent. Well, thank you, Dan. I know you've got some cool stuff to show us, and we're going to give you a little bit of a taster of the kind of work that does go on in a builder session. So yeah, Dan, do you want to share your screen? Seeing we unshared, the internet gremlins were not behaving in the beginning of this. So we had everything lined up, I promise you.
Let's see if it works. Yeah,
exactly.
So I'm going to just share with you, I'm going to be presenting a builder session on AWS step functions, which is a really cool service, and that I'll be sharing, I'll be describing to you in just a few minutes, but walking you through what it might be like to be at a builder session. And in mine in particular, I'll do a short intro to step functions, and then we'll get into some actually real live code. So I will share my screen. Just a sec.
I've got to say, Dan, I didn't mention it before, and I'm slightly jealous of the mountains behind. I know you actually live in Colorado, and I've never been to Colorado. I'm originally from South Africa, so we didn't have any snow there. But I've come into skiing later on in my life, so I look at those snowy peaks, and I'm like, oh, that must be nice to be in Colorado. I'll have to come and visit.
Yeah, I'd love to have you out. I live in Boulder, Colorado, and behind me you can see the Sangre de Cristo Mountains, which are in south central Colorado. They're a beautiful range. So I love it here.
Oh, very nice.
Okay. So the name of my builder session is Orchestration Patterns with AWS Step Functions. And it's, as I mentioned, it's a hands-on workshop, but it's also a level 200 workshop. So prior coding experience is not necessary in order to feel successful in this workshop. You're going to be able to get in there, and even if you have no coding experience, I promise you, if you just kind of engage with the materials, you're going to be successful and feel like you have learned a lot about step functions by the end of our session. And of course, you're welcome to sit and watch, but I'm going to encourage everybody at my table to really engage with the materials. I think you're going to get a lot more out of it that way. So just a quick agenda. We've done our introductions. You know me, you know Julian. So we'll skip that. And then I'll do a high-level overview of step functions. And then after that, after the overview, that's when I would distribute a code, and then everybody who is at my table can use the code then to get their own AWS account, and we'll start doing the hands-on workshops. And then I'm going to leave you with extra credit labs that you can do if you want to engage more deeply with the materials. So this workshop is designed to teach you 3 primary task orchestration patterns and step functions. And we'll go into them in a little bit more detail, but they're request response, sync polling, and callback patterns. The duration of this session is an hour. So let's talk about signs that might indicate that you need an orchestration service. So do you have an application that spans multiple AWS services? Is the sequence of service interaction important in your application? Does your application want to manage state between the various AWS service calls? Do you have an application workflow that requires a human intervention? Does your application contain workflow patterns like decision trees, branching logic, parallel processing, retries, error handling? If the answer is yes, then you might be a person who, or your application might benefit from step functions. So what are some of the most common orchestration patterns that we see in our applications? So you may want to sequence your tasks. For example, you may need to perform fraud detection, and then based on the results of that, you can approve or deny a credit card transaction. Or you may want to retry failed tasks. So for example, you may have a downstream service that occasionally fails, and you may want to implement retry intervals, maximum attempts, and back-off rates. You may want to run tasks in parallel. For example, a customer purchase could trigger services for accounting, inventory, fulfillment, and shipping. Or you may want to select tasks based on the data you receive. For example, you may have user-generated data that has different data processing and storage requirements based on its country of origin. Or you may want to implement a try, catch, finally type pattern within your application. Well, if that's the case, I'd like to introduce you to AWS Step Functions. So what is the Step Functions service? AWS Step Functions is a low-code visual workflow service that provides orchestration for other AWS services. And Step Functions support many common workflow patterns like retries, error handling, parallel processing, branching logic, has service integrations and observability. And Step Functions simplifies the implementation of these tasks so that developers can really focus on higher value business logic. Julian, this is a really exciting service, and it generates a lot of talk value among my colleagues. I don't know if you, about your perception of it, but I know a lot of my peers, at least in the solution architect community at AWS, think of step functions as sort of a paradigm shift in software development, offering a new top layer of abstraction for applications. And so I know a lot of people are really excited about it.
Dan, I 100% agree. And what I love most about how you introed it is you're not introing it from here is step functions, this is the kind of features from it. It's you have an application that needs to do some branching or parallel processing or decisions or that kind of thing, and actually approaching it from a business problem. These are kind of things that I need to do in my application, rather than thinking, well, which applications am I going to connect together? Yes, I could use Lambda for that. Yes, I could use EventBridge for that. Yes, I could use step functions for that. And this is actually the bigger picture that I see customers get excited about, is sort of looking at their applications and going, okay, what is the orchestration that we need to do in this application? And then start looking at step functions and then go, oh, wow, there's a lot of stuff, the retries and the error handling and the connectivity to SDKs and APIs and all that kind of thing built into step functions. And as people build out their application, then they only realize, oh, well, I don't need to have 20 Lambda functions. I only need 3 because step functions is going to do a whole bunch of it. This is a really powerful thing of using the services, and step functions is super powerful for that. And in fact, I would encourage you to model your business logic and then in fact look at step functions first, and then start plugging in Lambda functions where there aren't direct service integrations. And particularly when you're leveraging a whole bunch of different AWS services, look at step functions first to build up how your app is going to communicate, and then only do Lambda functions when it can't do it natively.
Yeah, it provides a really nice layer of abstraction that handles a lot of the common tasks that people have to do over and over again, and it handles it really gracefully, so that you don't have to.
Yeah, and it basically means you can remove a whole bunch of stuff which becomes brittle out of your code. So that anytime you've got too many, try, retry logic in your code, or you're taking an event and you're having to decide on something and then put it somewhere else, people are writing many, many lines in their Lambda functions to do that. You can externalize all of that and use the power of the AWS as a platform for retries and error handling and handle that logic for you.
Yeah, Julian, I don't know about you, but for me, I feel that the less code that I can put in my application, the better. I look at
definitely when it's the code I write. I don't want to do the code I write. Remove as much of that as possible. But yeah,
I look at code. Management of code as a liability, and it's really the features I want to implement. And if I can do it without writing code, or the fewer lines of code for me, the better.
Absolutely.
So let's talk about sort of some of the primary primitives and concepts within step functions. So the first thing that you should really kind of understand is, what is a workflow in step functions? So a workflow is a map of all of the logical pathways that can be executed within an application. And in step functions, workflows are written using a syntax called Amazon States Language, or ASL. We'll refer to it as ASL moving forward, and we're going to be learning more about ASL in this session. Workflows are referred to as state machines. So sometimes they're kind of synonymous, and people kind of interchange those concepts. And state machines are composed of steps that are also called states. And state machines can be used to orchestrate multiple AWS services. So an example of some of the states here, and you can see in a single execution, a state machine will begin at an initial state, and that state will execute some kind of action. And then it will pass control on to the next state in the sequence. And then that state will execute its action and then pass control forward again, and so on and so on. So the workflow continues to progress from state to state until it reaches an end state, after which it terminates execution. So this is a list of the primary states, state types within step functions. You have the choice state that allows you to make choices between branches of execution, parallel that can enable you to do parallel branches of execution. With the map, you can create a dynamic number of steps. So if your number of steps is unknown, but based on data that you receive, you can use the map state to map out your branches dynamically. The pass state simply passes its input to the next state, but it can also do some management of some of this data that gets passed from state to state. And we'll talk a little bit more about inputs and outputs. There's a wait, a succeed, fail, and then task is sort of your workhorse state that does that accesses other resources and performs your main tasks. So a step function's execution receives JSON text as an input. So at the very beginning, you pass it some amount of JSON that's sort of the input text. And then what the state machine allows you to do is actually manage a state of data from step to step and process that data as you move from step to step. So each individual state receives JSON as an input, and then it typically passes JSON as an output to the next state. And so in that way, you can manage state through your workflow. ASL provides tools to filter and manipulate and transform input and output between the states. We're not going to go too much in depth on input-output processing, but you should just realize that there are tools available for you to manage state between different steps in the data state between different steps in your workflow. This is a really exciting feature within step functions, just really recently announced. Actually, on September 30th, just recently this year, step functions expanded the number of supported AWS services from initially 17 to now over 200. And AWS API actions that are natively integrated into step functions from 46 previously to over 9,000. So you can use step functions as a bridge to virtually all of the other primary AWS services and incorporate those services and their API calls into your step functions workflows.
This blows my mind. This is just amazing. I kept sort of thinking of, what's the future of step functions? How's it going to integrate with more services? And they're going to keep adding services as a one-off. And then the experts on the product management team of step functions, hold my beer. I think we're just going to do all of them in one foul swoop, which is amazing. I mean, 9,000 API actions, all the number of times you having a Lambda function to use something like recognition or put something to DynamoDB. I know there was direct integration with that, but not for everything. Or something with, any integration you can possibly think of with any other service, even, something like EC2 or if you're connecting to, anything else that's not even serverless, one file swoop, you can just use the SDK and stroke of brilliance, whoever came up with that.
There's a common syntax for integrating with APIs, and you can see it here. So pretty easy to actually use within ASL. So step functions has two workflow types. The standard workflows are designed to support long-running, durable, auditable workflows. So think long-running. And these could be workflows that may need to take long pauses, perhaps even require human interventions. And then on the other hand, you have express workflows. And express workflows are designed for high volume event processing, such as IoT data ingestion, streaming data, mobile application backends. And in this table here, you can see some of the differences between the two workflow types. Most notable here is that a standard workflow can continue execution for up to a year, while an express workflow is limited to 5 minutes. With regard to state transitions, the standard workflow supports an initial bucket of 5,000 with a 1,500 per second refill rate, while express workflows support a virtually unlimited amount of state transitions. So each workflow type has different quotas and supported features, and you can explore these in the documentation. But in general, you should think, is it a long-running function? Does it need pauses? It's a standard. Is it high-volume event processing? I should use Express. This is another really cool innovation within step functions, and it's called Workflow Studio. So Workflow Studio is a low-code visual editor for designing workflows, and you can find it in authoring mode when you're creating or editing a workflow. And with Workflow Studio, you can drag and drop integrations and flow choices to form complex application logic. And we'll set aside some time in the workshop today to review this editor, but I should just tell you that working with the editor is actually really delightful. Sometimes you get into these kind of drag and drop browser experiences where they're a little bit wonky to use and not fun, and it's kind of hard to use. This is a really well done editor that allows you to really drag and drop and create applications pretty quickly through a really kind of delightful interface. I don't know, Julian, have you used it?
Yes, I have used it, and it's amazing. And I know internally, even at AWS, there are a lot of other teams who've gone, step functions people have raised the bar on creating this kind of interactivity. And yeah, all these sort of wireframe kind of things that you normally stick together can be pretty janky, but they've done an amazing job. It's fast, it's interactive, and ASL, the actual state's language, is all sort of in text and JSON, and it's understandable. You can follow it. It's with all that state, but to actually have it visually done where you can build it is amazing. Because step functions has always been great when you could view the executions of the state machine and you could see the whole path through. I always loved that, and to do this at the build step is amazing. So yeah, I have used it and I think it's excellent.
I know that some architects are actually using step functions with customers just to diagram out application architectures. So
that's what I've seen when I was talking about the original thing of, before you even start thinking about what technologies you're going to do, just using step functions to literally map out the business problem or the business process that people are looking at from the get-go. And even if you don't land up using step functions to do it, which I think you should, it's a really good graphical way to model your business processes. Okay, so just Jason says, is the editor free? Yes, it is free. So for step functions, you do pay the pricing that Dan was showing earlier. But yeah, all the other bells and features in terms of the console and how to use it and the Workflow Studio is definitely free.
So task patterns is where we're going to be spending most of the time in our labs today. And when you create a task with step functions by calling any of the over 200 integrated services, there are three main patterns that you can use for integration. So the first pattern is called request response. And when you use this pattern, step functions just proceeds immediately to the next step of the workflow without waiting for the underlying service to complete its job. So it's kind of like a fire and forget, and then it moves on really quickly. That's request response. The second pattern is called sync polling. And when you use this pattern, step functions monitors the underlying service, and it polls that service, and then only proceeds to the next step in its workflow when the service completes its job. It notifies step functions that it's complete, and then step functions moves on. And the last pattern is really interesting. It's called the callback pattern. So with this pattern, step functions actually provides a task token to the integrated service, and then it pauses and it waits. And then it only proceeds to the next step in the workflow after the token is returned. And the token can be returned by a different service entirely. But any service that basically calls step functions and passes the proper task token in, then notifies step functions that it can continue to advance. So that's a really interesting pattern for integrating with other services.
And even integrating with humans, I'm saying in inverted commas, because you can use the callback token to send it to some other system. A human could review it, could do a whole bunch of things, could land up taking something physically off a truck and putting it onto some other conveyor belt or something, and then they will come back and they can have some sort of IT technology that would hit an API or do something, which then would send that callback token back into the service, and the step functions carries on processing. So yeah, remember, these step functions can run up to a year. You can do some pretty impressive things, and just getting step functions to wait until you're ready.
So this is the point in the process where I would distribute a temporary AWS account to everyone at my table, and we've got a pretty good system for doing it. It's a system called Event Engine, and it distributes setup AWS accounts for temporary use for folks in the builder session. So let me switch screens now, and here is my console. And there's also a workshop with labs that goes along with it. So the first module here is just a hello world module. And the idea is really to just get somebody into the step function service and play around with some of the features. And so we'll just, let's do that. So the first thing that I'm going to do here is go to a task timer state machine. So I'll go into step functions and search for that state machine. And then we'll just take a look at it.
So this is also being really efficient within the builder session, that a whole lot of the infrastructure is already there for you. You can obviously go back and play and explore, but you're not actually, I won't say wasting time, but spending a lot of time within your builder's session setting up all the infrastructure. You can sort of get right in.
That's right. And so here you'll see we have a wait state, and then after the wait state, we send an SNS message. So the wait state here looks for a data called timer seconds, and then once it executes that wait, then it will send the SNS message. And so let's go ahead and cancel out of this, and then I am going to start the execution. And I'm going to pass in this JSON here that contains a message to go into SNS and also the number of seconds that the timer should wait. So start execution, paste my JSON, and then we'll start here. So while it's running, I can actually go down and look at the workflow as it's in progress. And after 5 seconds, it'll turn green and it sends the SNS message. So super simple workflow. And at this point, also, I just want to take a moment to show you what it looks like to play around with Workshop Studio here. So here's what it looks like. You can see on the left all of the different actions. These are the most popular actions, but if I scroll down, you can see all the different services. I can click into a service and get a list of the APIs for that service. Let's say I want to, and here's all the different flow choices. So let's imagine that I want to create a choice here, a choice state. And then depending on the outcome of that choice, maybe I do a Lambda invocation, and then, or maybe I do I could even do another step functions execution. So I can do sort of like a second step functions within the first step functions workflow. So there's just a lot of choices here. And then each state has its own configuration here. So I can configure things like retry policies and the specific Lambda function. Obviously, let's see here. So lots of different options for configuring each of the different states. Right. So let's go into module 2, and I'm going to show you how the request response works. We're going to review the ASL definition. Then we're going to execute a state machine using the request response pattern and inspect the results in the execution event history. Okay, so first we're going to navigate to the request response state machine. And when you specify a service in the resource string of your task and you only provide the resource, step functions by default doesn't wait for waits for an HTTP response from the service, but then immediately progresses to the next state. So the default for step functions is kind of the fire and forget model. And step functions doesn't wait for the underlying job to complete. It just moves on. And this is called the request response pattern. So let's take a look at an example. Whoops. Okay. Yeah, you can see here the SNS publish. And go ahead and start that execution. Now you'll see here, it'll wait for 10 seconds, but then it will execute SNS very quickly and then move on to the next state. So this is where below you can see the execution event history. So you can kind of observe within your step function state machine all of the different states that your step function went through and all the different timings. So you can see that it waited for 10 seconds and then it very quickly performed an SNS message, sent an SNS message, and then proceeded to the succeed state. You can drill into each of these.
And one of the really nice things I like about step functions is being able to look through the executions. You look at the inputs, look at the outputs, and that's so easy for your troubleshooting steps or understanding what's going. Each input and each output you can look at, and it's a really good way, rather than having to send something to another service like CloudWatch Logs and then look through the logs. You can do that as well, but it makes it much simpler to do it within the console here.
Absolutely. So now I'll show you a different pattern, which is called sync polling. And in this session, we're going to execute a state machine using an initial asynchronous pattern. So we're going to do the default sort of request response, fire and forget. But then we're going to modify the ASL definition to implement sync polling. And then we're going to execute the state machine again with the sync polling implemented. So let's take a look. We'll find in this particular lab, we're going to integrate with AWS Batch. So this state machine submits a job to AWS Batch, but doesn't wait for the job to complete. And instead, it immediately moves on to the next state and sends a notify success message to an SNS topic. And here's what the workflow looks like. So let's take a look here. Okay. So we can go into Workflow Studio. We can take a look. Looks good. We'll cancel out. And then we'll start the execution. So you see it went really quickly through and completed in 318 milliseconds. Now the batch job, on the other hand, is still executing, I'm guessing. So we can actually click through and look at the batch job, and it hasn't even really started yet. So it just kicks off the batch job and then continues to execute. So let's say that we wanted the step functions state machine not to proceed until this batch job was actually done, but instead we wanted the state machine to poll the batch job and then only proceed once the batch job indicated that it had either successfully completed its batch or failed. So in this case, we'll modify the definition of the ASL, and we'll add this .sync method to the end of the resource node. So you can see here, it even has a really nice convenience where I don't even have to type it. It just prompts me. It knows that I might want to add the sync method. So it gives me that option and I just click on it. And then I can save. And then I'll go back and start an execution. Now, Julian, you can see here in this case, we're paused at the submit batch job state. And what step functions is doing is now under the hood, it's polling AWS batch and waiting for batch to complete. And this is going to take a couple minutes. Oh, it's faster than I thought. So you can see two different patterns for how to manage how to manage integrations with other services here. And then the last one that'll demonstrate here is the callback pattern. So in this module, we're going to execute a state machine using an initial pattern, which is the default pattern. Then we're going to modify a Lambda function to actually implement the callback. And then we're going to execute the state machine again with the callback implemented. So we will navigate to the state function in our account. That is the wait for callback state machine. And we will start an execution. Now this execution is going to get paused here because it's waiting for a callback that it's never going to get. And so what we need to do is actually create the Lambda function that implements this callback. And so what this state machine actually does under the covers here is it sends a message. It actually sends the callback, the task token, to SQS. And then what I've done within this account is actually I've created a Lambda function that points to that SQS queue as an event source. And so the Lambda function is pulling the SQS queue, trying to receive the task token. And then, so we'll go over to the Lambda function and modify it. You can see it's configured to look at the SQS queue and pull that. And then here we have a Lambda function that receives an event and then looks for the task token message within that event. And then what we'll do is actually uncomment these two lines so that you can see we will invoke step functions. We were going to send a send task success. And within that, we are going to pass the task token as a callback.
So currently this SQS queue has a message waiting in the queue, just waiting to be pulled from it.
It actually does, yes. So I'll deploy this. And then we'll go back to step functions. Start an execution. And in this case, behind the scenes, it's going into SQS, and then Lambda picks it up, sends back the callback, and we end in success. So I'm going to pause there, Julian. It kind of gives you a taste of the type of labs that you might go through in my builder session. We go into a little bit more depth with some of the extra credit materials, but gives you kind of an idea of how to begin interacting with this service and the type of value that the service might provide for you.
No, Dan, super appreciated. I can exactly see what the builder session is like. Interactivity. There are going to be 7 people asking questions, asking each other questions and new questions. And yeah, I really like this as a really great intro to be able to go through in step functions in particular. And there are builder sessions for a lot of other services. So yeah, have a look. You can filter in the reInvent schedule for a builder session, and hopefully there is one available. And if there isn't, go and sneak up in the door outside, queue a little bit, and hopefully you'll be able to get in. While you are here, seeing you in a builder session, we can pretend with some questions. How do I export the step functions workflow to code so it stays replicable? Sorry for my bothering that. TypeScript tea time. You can export your Amazon States definition from the console. It stores it as a JSON file, and you can use that in AWS SAM. You can use it within. I know you spoke about Terraform afterwards. I presume Terraform. I'm not entirely sure, but sort of anything that can read step functions definitions from a JSON file. Would be able to use it. Dan, is that all correct, or am I?
Yeah, that's absolutely correct. I did a session on YouTube a little while ago about SAM Accelerate, and so SAM Accelerate enables you to actually sync your ASL file with your cloud environment. So as you make incremental changes to your ASL file locally using SAM, then those changes actually get synchronized in real time to step functions, and it's a really cool way to do iterative development in your cloud native environment at more quickly and more efficiently.
Yeah, and SAM Accelerate. If you're doing anything with serverless, please go and have a look. It is awesome. It's in one day. As soon as it came out, it became my default to build kind of stuff. Super good for local development. You literally save your Lambda functions, save your states definition or your API config, syncs to the cloud, test immediately. Can't get any better. That would be great. James had a question. Also, how would I call a step functions from an app, say a React app? Dan, what would you suggest?
Let's see. You can invoke step functions through its API from a React app. So that would be one way to contact it. Julian, you have other advice?
Well, I was thinking. There are a few things you could do. You could put step functions behind API gateway. So if you did have a common API within it, if you don't want to call the step functions API directly. Also, your React app may be doing some things that you do need to be synchronous, which you do need synchronously. Fine, use the API. But then anything that's asynchronous, maybe step functions is going to do some kind of workflow to, I don't know, to user creation or to do some sort of asynchronous process. And you could then have that behind an API. Maybe a Lambda function is going to kick off step functions, or I think API gateway talks directly to step functions as well. There are a number of ways. Have your front end app either directly via step functions API behind API gateway, and behind API gateway you could do step functions directly, or via Lambda, or some other kind of thing. So yeah, they're going to be different ways that you're going to be able to do it. We have run out of time. Sorry for the last few 10 minutes in the beginning, but thanks so much. We're back again next week for pre-invent session number 4. Eric Johnson's going to be hosting with just some cool new stuff. Hopefully it's going to be cool. So really appreciate Dan, you joining us today and showing what a builder session is like. Hopefully you're going to be able to come to reInvent. If you do, please come up and say hi to Dan and myself. We'd love to meet you. And if you are not attending reInvent in person, still get on the session planner, find out all the things that are going to be done remotely for virtually, so you can get as much information, and we can help you with whatever you need to build your serverless applications. So Dan, thank you. I really appreciate you taking the time today, and that was a super demo. Thank you very much.
You're welcome.
Cheers all. Have a good day, and hopefully see you in reInvent or virtually.